Okay, welcome to our last unit of this here. This is Unit 9, which is all about function families. We're going to be comparing lots of different types of functions, and we're going to start in this first lesson by reviewing one of the first lessons that we learned about, one of the first functions rather that we learned about this year back in Unit 4, a linear function. So you can see our learning target says that I can transform a linear function by changing the slope or the y-intercept. So just to give ourselves a warm-up to this lesson, our do now says given the following two functions, f of x and g of x, they want to know what is similar and what is different. So let's take a look at the graph of these two functions. So notice here I graphed y equals 2x plus 1 and y equals 2x minus 3. So first we have 2x plus 1 in red, then we have 2x minus 3 in blue. So what we notice is the same about these functions is their slope. Remember, the slope is the rise over the run. Both of these functions have a slope of 2 because to go from one point to the next, you move up 2 and to the right 1. So what they have in common is they have the same slope. What they have different is their y-intercepts. Remember, y-intercept means where the graph crosses the y-axis. Our first function you can see here is a y-intercept of 0, 1, whereas our second function here has a y-intercept of 0, negative 3. So to come back here, so what is similar about these two functions? We saw that their slope was similar, and their slope in this case was 2, which means to go up 2 and to the right 1. What was different about these functions was their y-intercept. Again, y-intercept where it crosses the y-axis. Our first function had a y-intercept of 0, 1. Our second function had a y-intercept of 0, negative 3. So just reviewing these two important terms, let's go and take a look at our new packet here. You're going to want to be in the packet called Functions Families Part 1, and we're going to be at the top of page 1. So before we kind of dive into what's in this chart, let's think about this think, write, pair, share question, which says, what do they mean by function family, parent function, and function transformations? So go ahead, take a second to think about those title phrases and what they might mean. So starting with a function family, we notice, again, our first family that we're talking about today is a linear function. Well, if you think about a family is a group of people in some cases, and they're a group that they have something in common. So the group of functions or the type of functions that we're talking about in this lesson is a linear function. The next phrase that we have here is a parent function. So if you think about like a parent in a family, the parent is usually the original or the starting. So our parent function, when we use that phrase in any of these lessons, means our original function. So in the case of a linear function, the original parent function is going to be y equals x. And that's this graph right here. It's a nice straight line here. It goes through the origin. It has a domain and a range of all real numbers. And we know that we can also write our parent function as y equals mx plus b. And just to remind ourselves, we remember that m is our slope, and b here is our y-intercept. So those are the two key features that we can change about our original parent function. And finally, we have a function transformation. Well, to transform something means to change it. So we are going to think about, well, how can we change these original functions that we have? Now, in the case of a linear function, there's essentially two things that we can change. We can change our slope or our y-intercept. So you can see here the first two boxes talk about changing the y-intercept. So if we increase that value of b, that's going to move the whole graph up because the y-intercept is being moved up. If we decrease the value of b, that's going to move our graph down because the y-intercept is being moved down. Then the other thing that we can change in our second chart here is the slope. And basically, there's 4 different things that can happen. First, we could have a negative slope. That means that our graph is going down and to the left. And obviously, that happens if our value of m is a number less than 0. Or we can have a positive slope, which is when we have a value greater than 0. The other thing that can be changed about the slope, other than positive or negative, is how steep it is. So the phrase steep, think like you're climbing up the stairs. When it's harder to climb up, that's more steep. When it's easier to climb up, it's less steep. So you'll see here, the larger that the number gets, like -2, -3, +2, +3, that's going to make our graph more steep. If the numbers are smaller, let's say like 0.5, -0.2, that's going to make our graph less steep. So as you can see in this chart here, again, there's 2 ways that you can transform a linear graph. You can change the y-intercept by moving the graph up or down, or you can change the slope by making it negative or positive, or changing the steepness of the graph. Let's take a look at our guided practice. In the graph here, they're giving us a graph of f of x, which is x plus 3. In part A, they're asking us to graph a new function g of x and identify how it was transformed. And in part B, we're going to graph h of x and identify how that was transformed. So again, we always want to compare our linear functions back to the original parent function, mx plus b. So if we look at the given graph here, we would see that m would be an invisible 1 because there's no number here in front of our x, and our b would be positive 3. So that means that our slope is 1 over 1, up 1 to the right 1, and our graph crosses the y-axis at 0, 3. Looking at the function in A, we see that our new slope is going to be -2, and our new y-intercept is going to be 3. So you can go ahead and use an online graphing calculator to try to graph this. I'm going to just graph mine by hand. And that graph would look something like this. So this is our graph of g of x. And then it says, how is that graph transformed? So you'll notice that what has not changed is the y-intercept. This graph still crosses at 0, 3, but what did change was the slope. My slope was originally +1, and now it's -2. So the transformation that happened is that the slope became negative. It changed from a positive to a negative. And it also became more steep. Right? You'll notice that that line, although it's negative, it kind of goes up and down a lot more than our original graph, which means that it is more steep. Let's take a look at part B. Here we're being asked to graph h of x. H of x would have a slope of an invisible +1 in front of that x, but it would have a y-intercept of -3. So notice that I went back to the same original slope as f of x, but the y-intercept was changed. So let's use a graphing calculator to see what that graph would look like. So you'll see here is our graph of h of x. So if we compare that back to our original graph, we'll notice that what did not change was the slope. See, those 2 lines are parallel. The slopes are still the same. But what did change was the y-intercept. Here it was at 0, 3. Here it's at 0, -3. So how is it transformed? We can say the y-intercept changed from 0, 3 to 0, -3. So again, to summarize, there are 2 ways that we can transform a linear function. You can change the slope, or you can change the y-intercept. So let's go ahead and try our checkpoint question. Try to pause this video and see if you can answer these questions, and then come back to check your work. So our original parent function was y equals x. So you'll notice here that it started by having a slope of an invisible +1 and a y-intercept of 0, because I did not see a number there. So looking at our a of x function here, we see that now this has a slope of 3. So how this was changed is that the slope changed from 1 to 3. And what does that mean? That means the graph is more steep. Okay, if you were to take a look at an online picture of a graphing calculator, you would see that that line is still a positive slope, but it's a lot more steep. It rises much more quickly. Looking at part B, I noticed that what was changed here was adding this positive 4 in the end, which means that our y-intercept is now changed to 4. So the slope went back to being positive 1, but what changed was our y-intercept. So for part B, the y-intercept was changed from being at 0, 0 to being at 0, 4. And what does that mean? That means that our graph is moved up because our y-intercept was increased. Okay, so thinking about how you did on this checkpoint question, let's take a look at our independent practice. If you weren't able to answer either part correctly, please start with the red questions. If you got one of those two parts correct, or you just weren't detailed enough in your answer, try the yellow questions. And if you got both parts completely correct, please try green. So go ahead and pause this video and then come back to check your work. Okay, so at this point, you should be checking the work that you've already done. Feel free to pause the video to check your answers. Here's numbers 1 and 2 on page 1. Here's numbers 3 through 5 on page 2. Here's numbers 6 through 8 on page 2. So if you have any questions about anything from this lesson, feel free to send us an email to set up a time for extra help. The last thing that you should try to do is the first question on this exit ticket. Don't submit the exit ticket quite yet, but now you should be able to answer question number 1 on your exit ticket, and you should also be able to now answer question number 1 on the homework as well.